Every single night you lose consciousness, your muscles go limp, your eyes roll back. Your awareness of the world around you, completely gone. And you'll do this for roughly 8 hours, every single day. That's 1/3 of your entire life spent unconscious. Now, from an evolutionary standpoint, that sounds like a catastrophic design flaw. While you're asleep, you can't run from predators. You can't find food. You can't protect yourself or the people you love. You are, for all practical purposes, vulnerable. And yet, every single animal on Earth that has a brain sleeps. Dolphins sleep, whales sleep, even fruit flies sleep. So why would nature, a process that ruthlessly eliminates anything that doesn't serve survival, preserve something this risky across millions of years of evolution? The answer isn't what most people expect. And it's happening inside your brain right now. Meet Daniel. Daniel is 26 years old, works at a mid-sized marketing firm, and has the most important presentation of his career tomorrow morning. His slides aren't finished, his talking points aren't polished, and the clock on his laptop reads 1:47 a.m. So Daniel makes a decision millions of people make every week. He decides to pull an all-nighter. At 2 a.m., Daniel feels productive, sharp, even. The caffeine is working, ideas are flowing, and he's convinced the sacrifice is worth it. By 4 a.m., he's rereading the same paragraph for the 5th time without absorbing a single word. By 7 a.m., when he finally closes his laptop, he feels a strange kind of wired exhaustion, too tired to sleep, too foggy to think clearly. The presentation doesn't go well. He forgets key points he rehearsed a dozen times. He misreads a question from his manager and gives the wrong answer. In the car ride home, a colleague says something mildly critical and Daniel snaps, completely out of proportion to what was said. He's not weak. He's not unprepared. His brain has simply been denied something it desperately needed. But what, exactly, what is sleep doing that when you remove it, everything starts to fall apart? Here's the first thing most people get wrong about sleep. They think the brain shuts down. It doesn't. In fact, during certain stages of sleep, your brain is nearly as active as it is when you're wide awake. What changes isn't the level of activity. It's the asterisk-type asterisk of activity. Sleep happens in cycles. Each cycle lasts roughly 90 minutes, and across a full night, you'll move through 4 to 6 of them. Inside each cycle, your brain passes through distinct stages. The first are light sleep. Your body temperature drops, your heart rate slows, and your muscles begin to relax. This is the transition zone, the threshold between wakefulness and deep rest. Then comes slow-wave sleep, what scientists call deep sleep. This is the most physically restorative stage. Your body is doing heavy repair work here. Tissue growth, muscle recovery, hormone regulation. And then, the stage most people have heard of, REM sleep. Rapid eye movement. During REM, your brain becomes extraordinarily active. Your eyes dart back and forth beneath your eyelids. Your body becomes temporarily paralyzed, a biological safety mechanism that stops you from physically acting out your dreams. And this is where some of the most fascinating things in neuroscience are happening. Your brain, during REM, isn't resting, it's working. Imagine spending an entire day doing nothing but receiving emails, thousands of them. Important ones, irrelevant ones, urgent ones, spam, all pouring in at the same speed with no time to sort through any of it. By the end of the day, your inbox is chaos. Now imagine that every night, while you sleep, a highly intelligent system goes through every single one of those emails. It files the critical ones into labeled folders. It connects related messages into threads. It permanently deletes the ones that don't matter. And it highlights the most important ones so you can find them instantly the next morning. That is what your brain does with your memories while you sleep. During the day, your brain is constantly absorbing information, conversations, facts, emotions, experiences. but it doesn't have time to properly process and store all of it. Not while it's simultaneously managing your body, your attention, and every decision you're making in real time. Sleep is when that processing finally happens. During slow-wave sleep, your brain replays the experiences of the day, strengthening the neural connections that represent important memories and weakening the ones that don't need to be retained. During REM sleep, it goes even further, connecting new information to existing knowledge, finding patterns, drawing associations. This is why you sometimes wake up with a solution to a problem you went to bed puzzling over. Your brain was literally working on it while you slept. Studies have consistently shown that people who sleep after learning something new retain significantly more of it than people who stay awake. Sleep doesn't just protect your memories, it enhances them, which is why Daniel, who skipped sleep the night before his presentation, couldn't access the information he'd spent days preparing. It never got properly filed. Now here's something that most people, including many outside the neuroscience world, have never heard of. And honestly, when researchers first discovered it, it changed the way scientists think about why we sleep. Your brain, unlike almost every other organ in your body, does not have a traditional lymphatic system. The lymphatic system is your body's waste removal network. It collects cellular debris, toxic byproducts, and metabolic waste and flushes them out. But the brain was thought to be cut off from this system. Scientists couldn't figure out how it cleaned itself. Then, in 2013, a neuroscientist named Micah Nedergaard and her team at the University of Rochester made a remarkable discovery. The brain has its own private waste removal system. They called it the glymphatic system. Here's how it works. While you're awake, your brain cells, neurons, are tightly packed together. There's very little space between them. Cerebrospinal fluid, the clear liquid that surrounds and cushions your brain, can only trickle through. But when you fall into deep sleep, something remarkable happens. Your brain cells actually shrink by up to 60%. The spaces between them expand dramatically, and cerebrospinal fluid rushes in like a flood, sweeping through your brain tissue and flushing out the waste products that have accumulated throughout the day. Think of it like a city during the day. The streets are packed with people, vehicles, and activity. Waste builds up on every corner, but there's no room for the cleanup crews to move through. At night, when the streets empty out, the crews come in and clear everything. Your brain does the same thing, but only when you sleep. And among the waste products, the glymphatic system clears beta-amyloid and tau proteins, the same toxic compounds that accumulate in the brains of people with Alzheimer's disease. Chronic sleep deprivation doesn't just make you tired. It may, over time, leave your brain swimming in waste it was never given the chance to clear. You've probably noticed it yourself. When you're exhausted, you get sick more easily. And when you're already sick, all your body wants to do is sleep. That's not a coincidence, that's biology. Sleep and your immune system are deeply, directly connected. While you sleep, your body ramps up the production of cytokines, small proteins that play a critical role in coordinating your immune response. Some cytokines promote sleep itself, others target infection and inflammation. During deep sleep, your immune system essentially conducts a patrol, identifying damage, repairing tissue, and reinforcing defenses. It's also during sleep that your body produces more T cells, the immune soldiers responsible for detecting and destroying infected or abnormal cells. Studies have found that people who sleep fewer than 6 hours a night are more than 4 times more likely to catch a cold when exposed to the virus, compared to people who sleep 7 hours or more. 4 times more likely, not a small difference. Sleep isn't a passive state your body tolerates. It is an active biological process your immune system depends on to function. So, what happens when sleep is taken away? The answer is more alarming than most people realize, and it gets worse the longer it goes on. At 24 hours without sleep, your cognitive performance drops to a level equivalent to having a blood alcohol concentration of 0.10%, above the legal driving limit in most countries. Reaction time slows, short-term memory begins to fail. Emotional regulation deteriorates, small frustrations feel disproportionately large. Sound familiar? That was Daniel at his presentation. At 48 hours, the body begins to experience microsleeps, brief, involuntary episodes where the brain essentially forces itself offline for a few seconds at a time, whether you want it to or not. Your immune response is measurably weakened. Concentration becomes nearly impossible. Simple tasks require enormous mental effort. At 72 hours, the brain begins to break down in ways that are genuinely frightening. People experience hallucinations, seeing, hearing, or feeling things that aren't there. Paranoia sets in. The ability to perform basic cognitive tasks collapses almost entirely. In 1964, a 17-year-old student named Randy Gardner stayed awake for 11 days as part of a science experiment, setting a world record. By the end, he was hallucinating, unable to complete sentences, and had lost basic motor coordination. The longest documented cases of total sleep deprivation in humans end in death. And in animal studies, complete sleep deprivation is invariably fatal. Sleep is not optional. Your body knows this even when your schedule pretends otherwise. Think about a time when you were truly exhausted. Maybe you snapped at someone you love over something small. Maybe you sat in a meeting and couldn't hold a single thought for more than a few seconds. Maybe you cried at something that, on any other day, wouldn't have fazed you at all. You probably blamed yourself, your mood, your patience, your focus. But maybe it wasn't a character flaw. Maybe your brain simply hadn't been given the time it needed to do its job. Sleep is one of the most misunderstood processes in human biology. We live in a culture that treats it as lost time, hours stolen from productivity, from ambition, from the relentless pace of modern life. But the science tells a completely different story. While you sleep, your brain is consolidating everything you learned that day. Your glymphatic system is sweeping out toxic waste that, if left to accumulate, may contribute to neurodegenerative disease. Your immune system is rebuilding. Your hormones are rebalancing. Your emotional circuits are resetting. Sleep isn't the absence of life. It is one of the most essential biological investments your body makes every single night. The next time someone tells you they'll sleep when they're dead, the science suggests they might be speeding up that timeline. If you just discovered something about your own body that you didn't know before, that's exactly what MedSimplified is here for. Every week, we take the most complex, fascinating questions in medicine and health, and we break them down so they actually make sense. Subscribe to MedSimplified, where medicine meets simplicity. And we'll see you in the next one. MedSimplified, where medicine meets simplicity.